solubility of a our next topic in the lesson solutions is solubility. The solubility of a substance is the maximum amount of that substance that can be dissolved in a given quantity of solvent. Now, the factors which decide solubility are nature of solvent, nature of solute, temperature, and pressure. Now consider the solubility of solids in liquids. The rule is like dissolves like. The meaning of this is structurally similar substances can mix well to form homogeneous mixture. For example, ionic solids will dissolve in polar solvents. For that, an example, sodium chloride dissolves in water. This is because the interaction between NaCl and water is strong enough to break the crystal lattice of NaCl. The interaction is ion-dipole interaction. So that is strong enough to break the crystal lattice, and hence NaCl dissolves in water. Whereas NaCl is insoluble in organic solvents like kerosene. That is because the interactive force between NaCl and organic solvent is ion-induced dipole interaction, which is weak. It's not strong enough to break the crystal lattice, and hence NaCl is insoluble in organic solvents. Then covalent compounds are soluble in non-polar solvents or organic solvents. Covalent compounds, the intermolecular forces present, van der Waals forces. And organic or non-polar solvents, intermolecular forces are van der Waals forces. So they have structural similarity and the interactive forces are similar, and therefore they can mix well. For example, naphthalene can dissolve in an organic solvent because interactive forces are similar. There are a large number of covalent compounds which are soluble in water also. For example, sugar or urea, glucose, alcohol. They are all covalent in nature, covalent compounds, but are soluble in water. And this is because they have polar groups in them which can form hydrogen bonds with water. And therefore, these substances are soluble in water. Then during dissolution, there is an equilibrium, or there will be an equilibrium between the dissolved substance and undissolved substance. Dissolved substance in solution, say the solute, for example, if it is sugar in aqueous solution and undissolved sugar or solid will exist in an equilibrium. And a saturated solution is one which cannot dissolve any more of the solute at a given temperature. This means that it contains the maximum amount of the solute it can contain at the given temperature, while an unsaturated solution is one which can dissolve more of the solute. Now coming to the next factor which can affect the solubility of solids in liquids is temperature. Now, when explaining temperature, we must know the nature of the dissolution process. The dissolution of a solid in liquid can be exothermic or endothermic. For example, if you dissolve NaOH in water, lot of heat will be liberated. In that case, delta H we say is negative. Or if you dissolve ammonium chloride in water, then you will notice a cooling effect is produced. And so we say the process is endothermic, for which delta H is positive. Then we can apply Le Chatelier's principle to explain the effect of temperature on the solubility of such dissolution processes. So if the dissolution process is exothermic, according to Le Chatelier's principle, solubility of the substance will decrease with increase in temperature. And similarly, If the dissolution process is endothermic, solubility of the solute in that solvent will increase with increase in temperature. And now coming to the next factor, that is pressure. Now again, considering solids and liquids, you know that they are highly incompressible. So pressure does not have any effect on the solubility of solids in liquids. So point is, pressure has no effect as solids and liquids are incompressible. Now coming to the next, solubility of gas in liquid. This can be explained using Henry's law, which you already know. So as according to Henry's law, the solubility of a gas is directly proportional to partial pressure of the gas in a given solvent at a given temperature. We can connect or relate the solubility to mole fraction, and therefore we can say mole fraction of a gas in a solution is directly proportional to partial pressure of the gas over the solution. And the most common form of Henry's law is that most common statement we use is partial pressure of a gas in the vapor state is directly proportional to mole fraction of the gas in the solution. And if we represent it mathematically, partial pressure P is proportional to mole fraction. And that means P is equal to a constant into mole fraction. And here this constant represented as Kh is called Henry's law constant. And this equation, if you look at this, you will find this is in the form y equals mx plus c, which is an equation of a straight line. And therefore we can represent Henry's law graphically. Along the y-axis we can represent partial pressure P, variable is mole fraction, along the x-axis. So we get a straight line passing through the origin. Again, considering the equation P equals Kh into mole fraction, you find the relationship between Henry's law constant and mole fraction, and that is here Kh. If you take Kh equals P partial pressure by mole fraction, they are inversely related. And this means that when Kh value is high, solubility of the gas will be less. So a gas having lower Kh value is more soluble than a gas having higher Kh value in the given solvent. Then there are some important applications of Henry's law. Soda water bottles or soft drink bottles are sealed at high pressure. Now this is to increase the solubility of carbon dioxide in them, because as per Henry's law, you increase the pressure solubility, more of solubility of CO2 increases, so more amount of carbon dioxide can be dissolved. Then another point is about scuba divers using air diluted with helium for breathing when they go deep into the sea. This is because at high pressure, solubility of atmospheric gases in blood is high. As they come to the surface, pressure decreases, so dissolved nitrogen will be released from the blood in the form of minute bubbles which will block the capillaries, and this will lead to severe pain and a condition called bends, and this can even lead to death. So to avoid that, they use air diluted with helium, because solubility of helium at high pressure in blood is very less. Then another point is about anoxia. This is a condition suffered by people living at higher altitudes and also by climbers, because at higher altitude partial pressure of oxygen is less, and therefore concentration of oxygen in blood will be less, and hence the people at higher altitudes they become tired, or they become unable to think properly, and that condition is called anoxia. Then the next factor, this is about the effect of pressure on the solubility of gas, which we explained using Henry's law. And now coming to the other factor, that is temperature on the solubility of gas in liquid. And now here, when a gas dissolves in liquid, it goes into solution. So this is like gas going into solution can be considered as a condensation process. Now in condensation, we know that gas changes to liquid. And if you consider the heat change during this process, we know when gas condenses, heat is liberated, and that is delta H is negative. So the process is exothermic, and hence we can apply very easily Le Chatelier's principle here in the dissolution of gas in liquid. Since the process is exothermic, when temperature increases, solubility of the gas in the liquid decreases. So when with increase in temperature, solubility of the gas in the liquid decreases. Since the dissolution process is an exothermic process. And this is one reason why we find aquatic species are more comfortable in cold water than in hot water. Because in cold water, the solubility of oxygen will be more, so more oxygen will be present. Whereas in warm water, the amount of oxygen in the dissolved form will be less, so aquatic species are not so comfortable in warm water. These are the important points of Henry's law.